Hello, hello.
Yes, sir, you are audible.
The screen is visible.
Yes, sir.
Okay. So I gave you some things to work out, right? I gave you some exercises. So how much have you progressed, if any? Hello. What were the exercises?
Page number 65.
Page number 65, right? See again, this book I recommended you because of its theory. Because its theory is really easy to read and you can reproduce it in the examination hall. But as I told you that these exercises are extremely hard. I mean, this is the book which has given me the hardest time. Not a single exercise is doable here. I mean, doable means it's doable, but it will take a lot of effort. So, like this one, 5. Have you tried it? শ্রীনা ট্রাই করেছিস কি অন্তত?
না দাদা করা হয়নি, তবে এই ট্রায়াঙ্গেলেরটা আমি করেছি আগে।
Anyway, I mean, I will have to solve this book because I will have
দাদা
to.
কিছু কিছু জায়গায় হিন্ট আছে কিন্তু মানে সেইগুলো বোধগম্য হয় না একদম।
It will take a lot of dedication. Maybe 2 or 3 times after reading the theory, you will get some intuition. Okay, so this is problem 6, right? Or problem 5? Problem 6, right? First, let me draw a picture. So the problem says that if omega is an open set of C and T is a triangle uh, inside omega whose interior is also contained in omega. Suppose that f is a holomorphic function on omega except possibly at a point omega inside T. Prove that. Prove that if f is bounded near omega, then integration fz over T is 0. So First, let's draw this triangle. Omega be like just this. Okay. So omega inside it, and this is small omega, this is capital omega. Now observe that we will do a few things. Okay. Now observe what we are doing. Okay. Let's name them A1, A2, A3, A4, A5, A6. So basically we have been given that this is T, right? This is T. So observation 1. F is holomorphic. Since F is holomorphic on all of omega apart from just W, so F is holomorphic on AI, right? Or holomorphic on an open set.
দাদা এটা তো কচি থিওরামের প্রুফের মতনই হচ্ছে জিনিসটা।
Exactly. ওই কারণেই তো বললাম যে you need to go through the theory first. On an open set containing on open sets containing AIs and contained in omega minus, like this there are sort of open sets like this, right? Like this sort of open sets which do not intersect W and which are completely contained in omega. So F is holomorphic on every such open set, right? This way. So first we write that, okay, no, this is observation. Before going to observation 3, so we have to prove, what do we have to prove? We have to prove that this is 0, right? T, we have given a direction to T. We have to show that this is 0, right? So let's break down the arrows first. Like use this. So let's break down the arrows. Then let's do one thing. This way, this way, this way. Oh, sorry. This is right, this, right? Okay. And this way. This is like, this is the circle, this is the triangle here, this, and this. So again, for this, we are going through this, by this, coming back to this. Then again, for this, you are going this way, coming this way, going this way. Now, look at that. Look at these lines. Here, the directions are opposite to each other, right? So, they are cancelling each other, right? Look at these lines. They are cancelling each other because one arrow is this way, another is this way. One arrow is this way, the opposite arrow is on the opposite direction. Okay. So, look at this. Going around T, this is counterclockwise. This is counterclockwise or clockwise? This is counterclockwise, right? You are going through this, you are not, first you are going like this. Now you are going this way, that way, that way, and that way. Now again this, again this. That is, you have broken the domain into several parts. Okay. So, observation 2. If integration over AI, if is 0, right? Because these are if is holomorphic on these triangles. Observation 3.
দাদা মাঝখানে ট্রায়াঙ্গেলটা কিছু নাওনি?
Exactly. Let's call the triangle here T epsilon. T epsilon. Okay. Observation 3. Integration f. Integration f t is basically summation integration f ai, I running from 1 to 6 plus f t epsilon. Is it okay? Is everyone at par with, is everyone okay with observation 3? So now we
Yes,
get
sir.
this. Okay. T epsilon be such that the perimeter of T epsilon is epsilon. Okay. Now, so from observation 3, we do like this. So mod is equal to mod is less than equals to mod where, since f is bounded near omega, f is sup fz, গন্ধ তো নেই কিন্তু তোমরা মাঝের বাড়ির শো বুঝলে, বা সামনের ঘরের শো আমি মাঝের ঘরে দেখছি, জানি না, মানে এখানে শুলে যদি পরে রাত্রে শরীর খারাপ হয়। নিয়ার around T epsilon. Okay. Because since f is bounded near small omega, fw, so we can do this. Now, letting epsilon tends to 0, because epsilon can be as small as possible, right? We get okay. Okay. You want to go through the proof again, or is it okay? Raghiv, is it okay? সবাই বুঝেছো?
তুমি এরিয়াটা ছোট করতে করতে মানে
Not the
করছো
area,
জায়গাটা,
the
তাই তো?
perimeter. The perimeter I'm talking about.
আচ্ছা আচ্ছা।
Okay.
তাই পেরিমিটার টার্মটা একটু লিখে দাও আর কি, নাহলে।
লিখেছিলাম তো।
ঠিক আছে।
Okay.
হুম।
So let's move on to the next problem. See, I can't give you infinite amount of time to try these problems because I have to complete the syllabus. I will have probably 8 more classes to complete complex analysis. So a hint is given there as well. So what are they saying? That if d to c is a holomorphic function, show that the diameter d, that is supremum, diameter of the image they are saying about it, the diameter of the image satisfies twice f prime 0 is less than modulus of twice f prime 0 is less than equals to d. Moreover, it can be shown that the inequality holds precisely if f is linear. Okay, let's see. A hint is given like twice f prime 0 is this according to them. Let's see whether twice f prime 0 is this or not. We know by Cauchy's integral formula. So by Cauchy's integral formula we know that this is Cauchy's integral formula, right? Formula we know f prime 0 is 1 by 2 pi I integration mod xi equals to r f of xi square d xi, right? By Cauchy's integral formula we can write it.
হ্যাঁ।
Okay. Let's see what can we do. Put xi equals to minus z. Okay. Then what do we get? Right? See, z is just a running variable, right? So we can just replace the variable because z is a running variable. Okay. So twice f prime 0 you get by 1 plus 2. This is 1, this is 2. By 1 plus 2 what do you get? 1 by 2 pi I. কিরে এত লেট হলো?
স্যার কালকে তো কমপ্লেক্সের ক্লাসটা হয়ে গেছে।
কিভাবে? কালকে রিয়েল এর ক্লাস হয়েছিল।
ও
আমি লিখে দিয়েছিলাম তো গ্রুপে যে কমপ্লেক্সের ক্লাস মন্ডে হবে।
ও আচ্ছা, আপনি মেসেজ করেছিলেন দেখলাম, তাই ভাবলাম হয়তো কমপ্লেক্সের ক্লাস ছিল।
আচ্ছা তোকে আমি ফোন করছি যাচ্ছে না, মানে তোর এমনি ফোনও যাচ্ছে না, মানে কি বলে ওটাকে বল?
না, ওটা এমনি ফোন আসবে না, শুধু হোয়াটসঅ্যাপেই আসবে।
আচ্ছা তো তো যাই হোক, একটা অঙ্কই হয়েছে, সেটা তুই দেখে নিতে পারবি, রেকর্ডিংটা তো আছেই। তুই এই অঙ্কটা একটু দেখ, আমাদের অঙ্কের স্টেটমেন্ট এটা, আমরা এটা করার চেষ্টা করছি। টেক 2 minutes, টেক 2 minutes। So this is the problem we are trying to solve. অনিশা ঠিক আছে?
হ্যাঁ।
আমরা কতটা এগিয়েছি সেটা দেখতে পাচ্ছিস? কিচ্ছু না, we have written down the Cauchy's integral formula and we have replaced z by xi by minus z, that's it, nothing else. Give me a minute just. Okay, so we are just adding them up. Adding them we get integration f xi minus f of minus xi by xi square mod xi equals to r d xi. Okay, this is what we get. Okay, so now what we do is just we take modulus twice mod f prime 0 is less than equals to 1 by 2 pi I modulus Okay, so now I think we can do one thing. This is less than d, right? This thing is less than equals to d, right? So let's put it. Now put xi equals to e to the power r into it, where 0 less than equals to t less than equals to t. This is the circle. Xi was the circle of radius r. So what is d xi? D xi is r I e to the power it dt. So put it here. 1 by 2 pi I mod 0 to 2 pi d by r square d by r. What is d xi? R I e to the power it. Sorry, this is to be a mod here as well. Dt. So what is this? Cancel this out. Cancel this I out. This is 1. So what do you get? This is 1 by 2 pi d by r 0 to 2 pi dt. Okay, it is d by r, right? So we get twice f prime 0 less than equals to d by r. Letting r tends to 1, we get learn these techniques. I mean,
দাদা r টেন্স টু 1 কি করে এখানে করে দেবে লাস্টের লাইনটা?
d is a unit disk, so r can be as close as 1 as possible, right?
হুম
That's what I have done.
Oh.
I have taken the limit basically. I mean, if you want to be more rigorous, then of course we can. So this implies twice f prime 0 is less than equals to limit d by r tends to 1. Okay. For all 0 less than r less than 1. Okay. That is a d. That's what I have done. See, don't get upset that you are not being able to solve these problems on your own. Okay. Because after reading the theory probably twice or thrice, I was able to do 30-40% of the problems. So that much dedication you will need to solve only 30-40% of the problems. So don't worry, again I am telling you, I am solving these problems because so that you can learn the tricks. The problems that you are going to come across in net are going to be way a lot easier. So we are not going to spend much time in the exercise solving of Stein-Chakraborty. This is a standard book, that's why I am giving it. Take it as a material. Go through it whenever you can. Then see what was 8. Like this part, I'm still trying this part. I'm still trying this. Like how to show fz is linear. That when f is linear, this is like this. Like the equality holds when f is linear. That is still a work in progress. I couldn't have time to go through this. So let's do 8. these problems are hardest by some margin. I would tell you, like, remember these things as a result, like number 6, like problem number 6. Remember this as a result. Okay. See, so what the problem is such that f is a holomorphic function on the strip -1 to 1. Okay, so let's draw the picture first. Okay, f is holomorphic inside this strip for all x belongs to R with, okay, fz satisfies this inequality where eta is a fixed real number. Okay, for all z in that strip, show that for each integer n greater than 0 there exists n greater than equals to 0, so that, okay, use the Cauchy inequalities. So first fix R such that 0 less than R less than 1. Define C Rx to be, like you can already guess probably, z belongs to C such that mod z minus x is R. Okay. So this is somewhere like here. Now what do we do? Given mod fz is less than equals to a plus 1 by mod z per eta. Okay. For z belongs to CRX, we have mod z minus x is R. Okay, and we all know this inequality, mod z minus mod x is less than equals to mod z minus x, that is equal to R. So this implies mod z is less than equals to R plus mod x. Okay, now mod fz is less than equal to a 1 plus mod z less than equals to e plus 1 plus R plus mod x whole to the power eta. Z belongs to, Okay, so this we have. So we can of course say that soup this. Do you remember this notation? Okay, I'm defining it again. This means the supremum of mod f z when z belongs to CRX. Okay, this is of course less than equals to a plus 1 plus r plus mod x whole to the power eta. Z belongs to CRX. Then no, Z belongs to CRX is not needed because of course it is already mentioned here. Then what do we get from Cauchy inequalities? What do we guess? Fix n greater than equals to 0. This is n. This is not eta. Okay. From Cauchy inequalities we get mod fn x is less than equals to n factorial by r to the power n soup. I mean this thing. Right. This is Cauchy inequalities, and this we have shown to be okay. Now this is less than equal to this. Right, as r is less than 1, right? Since r is less than 1, so 1 plus r is less than 2, so we can do this. Now this is less than n factorial by r to the power n a 2 plus this. No problem with this inequality because this thing is of course less than, because mod x is of course less than twice mod x, na? Take the 2 common. Okay. So fn x mod is less than equals to n factorial a 2 to the power eta 1 plus mod x, letting r tends to 1. Okay, so this is our an. Clear? Clear?
হ্যাঁ দাদা।
Do you guys want to have a look at it again? আরেকবার দেখতে চাও কি? তাহলে বলো। Okay. Just give me a minute. Okay, so sixty-five, 70, 70. So let's move on to 13. What is problem 13? Ah, this is a very good problem. Okay, so this is a very, very important problem. Uh, like I know right now you are probably feeling at a loss, but once we go to the okay, one thing you need to do is memorize all the statements of the theorems. All the statements of the theorems uh, from Shakarchi, because we will need that if we try to solve those MCQs from NET and TIFR, NBHM. Okay, so I want you to try this problem for at least 5 minutes, then I will solve it. At least try it because I know you haven't tried it. Use countability argument. That's the hint. You have 5 minutes. At least think about it a little bit. Devargo, you should be able to do it. आगे कोई issue है হ্যালো।
হ্যাঁ দাদা হচ্ছে একসঙ্গে।
হ্যাঁ, কতদূর?
ওই তোমার দেয়ার এক্সিস্ট লিস্ট এলিমেন্ট, মানে ওই সেক্টরের মধ্যে থাকবে এম, তাতে করে ওই এফটা এম অর্ডারের একটা পলিনোমিনাল আসছে আর কি।
হুম, দাঁড়াও। So, see what have we got? This is a power series expansion of f given around z equals to z naught, right? And they have said that for each z naught belongs to C, at least one least coefficient in the expansion such that uh, at least one least coefficient. So there exists in z naught belongs to natural number such that C in z naught is 0 and Cn is non-zero for n strictly less than n z naught, right? This is the criteria given. I mean, not the criteria. This is the condition given, right? That for each z naught there exists a natural number, call it n z naught, such that that is 0, and no Cn with lesser index is 0. Okay. So now there are uncountably many choices of Z0 in C, but only countably many choices of NZ0 in natural number. So there exists at least one N0 belongs to natural number such that if Z equals to n running from 0 to n Cn Z minus Z0 for n has Cn not equals to 0 for uncountably many Z0 belongs to C. Is it clear? Is the argument clear? এই রাগিব বলে ছেলেটা কি নেই ক্লাসে? প্রথমে ছিল না? Whatever. Is the argument clear? Because if for each n0 the choices of Z0 are countable, then C becomes countable because C becomes countable union of countable sets. So for at least one n0, the choices of Z0 should be uncountable. So now we make an observation or a note. Any uncountable subset of C has a limit point in C. Say or denote by an naught. We are denoting by an naught all those Z belongs to C such that or z belongs to C such that if z like summation Cn z naught whole to the power n has Cn not equals to 0 and Cn not equals to 0 if n less than n naught. So we have taken all z naughts and the collection we are calling it an naught. Any uncountable subset of C has a limit point in C. So how do we prove it? We know that C has a countable basis just as R2. We can take beta of the form xi plus iyi, or let's make this x plus iy, where x, y both belongs to Q. This is a countable basis of C. Check that this is a countable basis of C. Now no, how can this be a basis? The ball at x plus iy of radius r. Okay, so this is a countable basis, of course. So at least one of the balls have uncountable many elements of C. Say B x naught plus iy naught, r naught. Note that it is bounded. So by Bolzano-Weierstrass theorem, there exists a limit point of any uncountable subset. First we should name this uncountable subset, otherwise uncountable subset A of C has a limit. So at least one of the balls have uncountably many elements of A. Say Thus, A has a limit point. In our problem, replacing A by A n naught, we get that A n naught has a limit point. But what is A n naught? But what is A n naught? Remember, we wrote A n naught like this. If z equals to all those z naught such that if z equals to summation cn z minus z naught whole to the power n such that cn naught is 0 and cn is non-zero if n less than n naught, right? This was our cn naught. What is this? This is nothing but z naught such that if z is c naught plus c1 z minus z naught up to wait a minute. After that, what is cn naught is an naught? We know that. What is cn naught? Cn naught is nothing but if n naught z naught at by n naught factorial, right? That should be the coefficient of the power series expansion.
হ্যাঁ
Okay. Now, f is entire, right? This implies fn z is also entire, right? And an naught is basically the zero, or maybe I like to write zero set of fn z by n naught factorial, right? Implies fn z by n naught factorial is 0 for all z belongs to C, as an naught has a limit point, right? Thus, take the expansion about 0 to get fz equals to f0 plus f prime 0 z and so on. Okay, no. So do you realize that this, since this is 0, f is a polynomial? You understand that? Nth derivative of f is 0. I mean, what does it imply? This implies that this is 0.
হ্যাঁ
This implies f polynomial. f integer or
অনিশ্বাস
Oh. Okay. This was a problem which I came across in ISI entrance.
দাদা এই প্রবলেমটা আরেকবার বলো মানে আরেকবার
First, go through the problem again. Just statement of the problem. What does it say? Suppose f is an analytic function defined everywhere on C, and such that for each z0 belongs to C, at least one coefficient in the expansion of fz. So basically, they are taking the expansion, power series expansion of f around every point, and they are seeing that that power series expansion actually terminates after finitely many points of time for each z0, right? That's the statement. We have to prove that f is a polynomial. So what do? We first observe that there are only finitely many choices of n naught. I mean, finitely many choices of n, but infinitely many choices of z0, right? So there exists one integer for which uncountably many z0 are, and for uncountably many z0 admits that the expansion is expansion vanishes after cn naught, right? For uncountably many z0, we get this, that cn naught is 0 and like in the expansion of fz. Okay, so thus we define an naught. What is an naught? All those z0 such that cn naught is 0 in the expansion. Okay, now this is an uncountable set, and is this clear that every uncountable set in C has a limit point? Is it clear? This is not only true for C, this is true for any Rn, because any Rn is second countable. Second countable means any Rn has a countable basis. That is by the
না দাদা
mod.
এটাও
That clear নয়? I am defining this basis of R2. That is balls around x comma y of radius r. Okay, what is this thing? This thing is কি এত আওয়াজ কেন? where b, x, y r is basically all those x, y belongs to R2. Maybe I should write this like this. WZ belongs to R2 such that x minus w plus square plus y minus z square less than equals to r square. Okay, so this is a ball at x comma y of radius r. I have taken x, y, r everything to be rational. Well, you guys are having difficulty to understand it, but as far as recall, I gave you I think I gave you an exercise in Monkrus to prove that these sets actually form a basis of R2. What about that? If you are not doing the exercise properly, then I mean, if you are not doing the exercise of one subject properly, don't think that that will affect only that particular subject. So of course this is a basis, I mean, because for any wz belongs to R2, there exist, see, I mean, what have I taken here? There exist r greater than 0 such that b, x, y, r such that w comma z belongs to this, right? Because this is dense in R, na? Is it clear that for any yz belongs to R2 we have this? Oh, yes, okay. Fine, I mean, you can take this. Take x equals to box W, y equals to box Z, r equals to 1, then W comma Z belongs to b, x, y, 1. Okay. So beta covers C. Beta covers C. Now let this was 1, let b1 x1 y1 r1 and b2 x2 y r2 belongs to beta. Beta x1 y1 r1 intersection b2 x2 y2. Okay, suppose there exists w z belongs to this intersection. So what is that? So suppose this is a ball, this is a ball, this is at the center. Here we have taken some w. Okay. This is w comma z. This is my b1. This is my b2. This length is r1. This length is r2.
মিনিমাম অফ আটটাকে চুজ করতে হবে এবার, তাই তো?
হ্যাঁ, মানে আমি বলছি existence is enough actually. Again, you can choose a number, a real number close enough to this. There exists some ball, right? There is nothing.
ওই তো ওটাকে একটা নাম ডাব্লিউসি মিনিমাম অফ R1 মাইনাস
Yes, I mean this is
রুট
doable.
আবার মানে এরকম সেটা হবে।
Okay. So C has countable basis. Since C has countable basis, any uncountable subset A of C has a limit point in C. Why? Because again, by that countability argument, uncountably many points of A must be inside one ball. We call it this ball. Note that this is bounded because this is bounded by R naught, radius R naught. So by Bolzano-Weierstrass theorem, there exists a limit point of this set, right? So A has a limit point. Now replacing A by AN naught in our problem, we get that AN naught has a limit point. What is AN naught? What is Cn naught is AN naught? Cn naught is this. Since F is entire, this is also entire. So N naught is basically the zero set of this. Okay. This has a limit point. So this is 0. So this is a polynomial. Okay now.
হ্যাঁ ঠিক আছে।
রবিউল স্যারের ক্লাসে বসে অঙ্কটা করেছিলাম, ঠিক আছে? একটু খাটাখাটনি করো নিজেরা। অঙ্কটা সোজা বলছি না, কিন্তু প্র্যাকটিসটা অ্যাটলিস্ট করো।
আচ্ছা
ক্লাসে বসে করেছিলাম, 3 বছর বাদে দেখি এই অঙ্কটা আইএসআই লিখে দিয়েছে। মুশকিলটা হলো যতজনকে জিজ্ঞেস করেছি যারা সেই ক্লাসে ছিল তাদের কারুর মনে নেই অঙ্কটার কথা, কারুর মনে নেই। আমার এই জায়গাটাতেই আপত্তি যে এইরকম সিগনিফিক্যান্ট একটা অঙ্ক দেখে লোকে ভুলে যায় কেন? ভুলে যায় তার কারণ হচ্ছে এই অঙ্কটার ট্রিকটা মনে রাখার জন্য ব্রেনে যে ম্যাচুরিটিটা প্রয়োজন সেটা তাদের নেই, সেইটা আসেনি। কারণ হচ্ছে ওই ধরে ধরে শুধুমাত্র মানে ওই স্টেটমেন্ট ধরে ধরে অঙ্ক করা প্র্যাকটিস করেছে, যে কারণে কোনো ক্ল্যারিটি আসেনি সেভাবে। প্রতি সমাসান্তর ওই একই কাজ করে যায়। যাই হোক, আমি আবারও বলছি সব সাবজেক্ট ইনডেপথ প্রিপেয়ার হতে অনেক টাইম লাগে, সেটা হয়তো এখন তোমাদের পক্ষে সম্ভব না। তো আমি আবারও ওই একই কথা বলবো যে দেখো তো আমার ইয়েটা কোথায় গেল, পেনের খাপটা। তো আমি আবার ওই একই কথা বলবো যে আপাতত শুরু করো এটা দিয়ে, যে স্টেটমেন্টগুলো মুখস্থ রেখে অঙ্কগুলো করা শুরু করো। তারপর না হয় যদি ইচ্ছা হয় কমপ্লেক্স এক্সপার্টাইজ করতে, তখন কাম ব্যাক অ্যান্ড সলভ অল দিস প্রবলেমস। তোমাদের যা পারফরমেন্স দেখছি, মানে আই এম রিয়েলি ওয়ারিড in complex. I mean, not probably in the other subjects. Topology okay, but analysis is okay, very good. But in complex and linear, I'm really upset. So I'm thinking maybe I should go directly to problem solving for NET previous year's papers, and I will just probably give you the solutions, because I don't think you're putting in much effort in complex analysis. This is the 4th class, and I'm really not seeing any that sort of effort. I mean, the most effort you will be needing in complex analysis, because the books I have given you, the rest of the books, they are pretty basic. They are from basic to advanced, but this book is quite advanced in itself. So
কালকে ক্লাস হবে তো?
yes, linear
10:30
10:15. Okay, bye.